Hello, AP Statistics students. It's Miss Taylor again, and I am going to present your first home learning PowerPoint, and it has to do with categorical data and using two-way tables to find probability. I'm going to try to keep this under 10 minutes. Let's see if I can do it. Okay, so categorical variables, another name is qualitative. You can follow along with your notes. Identifying basic differential characteristics like a person's gender, race, color shirt they're wearing, type of car they drive, all those are categorical data. This is just an example of taking an example of collecting categorical data using AP exams. All right, so categorical data, when I collect it, I use count. So I'm just going to count how many people fall in that category. That's frequency. Relative frequency is the percentage or proportion of things, a proportion that falls in that category. And the distribution of the variables just shows all the possible 100% of the population or the sample I'm taking. And you can see all where everybody falls in the different categories for that situation or scenario you're sampling or looking up. Examples of categorical distribution graphs that we use, bars and circle graphs. And this is what we're looking at, the two-way table, also called as a contingency table. It's called two ways because I have two types of categories that I'm looking at. At the top, I'm looking at grade level, and on the side, I'm looking at gender. Hence, I have two different categories, a two-way table. All right, so our row variable and rows go this way. And then we have column variable, which will go up and down. So our column variable is grade and our row variable is gender. Is a 2x4. The reason why it's 2x4 because there's 2 choices for gender and 4 choices for grade level. It's 8 total cells. The total columns don't count as actual cells. Those totals are for the sum that we would look at in our first example. Totals again are the margins. So these are my margins. That's just not categories. That's just the sum of the data. All right, here we go. We know notation for probability. So this could be the probability of being a 10th grader. This is the one we're looking at now. It'll be the first time that we will see it. It's the probability of A given B. And so we'll talk about that when we get to our example. It's easier to do it that way. So the probability of A and B, there's some notation for it that you could see. And it is that symbol right there. It's the and symbol. And the probability of A or B is that symbol there. And there's a couple of ways you can think about the first one. And has an N in it. So this looks like an N. And I doubt if the notation comes up, but it's good to know what the notation means. All right, so here's our first example. So I'm going to give you a couple of seconds to go ahead and write this down. I will pause the video and I'm going to count. If you're not pausing the video right now, I'm going to go ahead and count to 5 and then I'm going to start back up. 5, 4, 3, 2, 1. So I hope you have these totals right here written down on your sheet. You need those totals to answer the question. So look at the first question. It's kind of common sense. So I'm going to click off my picture. What percent of people died? So it's not specific to which hospital. It just says what percent of people died. So obviously I need the total number of deaths, which is 79, out of the total number in my population between my two hospitals, which is 2,900. That's going to help me calculate the percent. So the probability of D, common sense, that would tell you is died. But you could always write it out just to make sure you hit that context that you're used to writing in statistics. We always need that. So the probability of dying or death of a patient is 79 out of 2,900, which is 2.72%. We want the fraction. The fraction shows your math that you did. So you do not have to convert it unless they specifically ask you for a percent. 79 over 2,900 is perfect for the AP exam. Don't keep going. Okay, so now let's go back and let's look at the next question. So our next question is, of those people that went to hospital A, and that's important. It says of. That right here is what we call a condition. It's telling us that we are no longer looking at the entire population of 2,900. I only care about people in hospital A. So hence, hospital A's total is going to become my denominator. Now I answer the question, what percent died? So here's what I look at. So who died at a hospital A? 63. So if I keep going, the probability of somebody dying out of hospital A, that's how you kind of read it, or the probability of a patient dying given you're looking at the people of the patients in hospital A. That's how you look at it. And so here's the math for it, and that's how you would do it. I wish I could look at Elle or Francesca's face to see if they're getting it. I wish I had a nod. I missed that to see if I'm going too fast. All right, here we go. So now let's go to the next one. Okay, so we have, given that someone went to hospital B, that is another condition. So that means I don't care about the total, and I don't care about hospital A. I care about hospital B. Because maybe it's the same group of hospitals, and they just want to compare, well, what's the percentage of death per hospital? Is one hospital doing better than the other? All right, so given that someone went to hospital B, what is the probability that they died? So I want that top number. So when I look for it, the probability of dying given that you were a patient in hospital B, that is how that's read. It's 16 over 800. Notice I did not do percentage there. I just left it. I didn't simplify it. I didn't write the decimal. These should be fast, easy questions for you to do. Next. Of the people who died. That's another way you can say of those people who died. So I care about everybody who died. So now my denominator is the 79. Now it says other people who died, what percent went to hospital A? Oh, well, here we go, 63. So now, let's look at that. So 79% of the people, or 63 of the people who died were from hospital A. Now, we can't say that's fair. We say, oh, hospital A had more people who died. But look how many more people go to hospital A. Hospital A may be in an urban city versus hospital B may be a country rural town. So you can't say, ooh, we got you. No, that's when something else comes in, when we compare something else. And we'll look at that at the end. Next. Now we have a different question. So we did our examples of the given and then our of if. Here we have a scenario. It says, what percent of the people died and went to hospital B? And means that you have to be in an intersection. You need to be in both categories. So you want people who died and went to hospital B. So they have to meet both criteria. So I have to go, okay, so where does it intersect? So died and hospital B, oh, that's where it intersects. Now the question is, what do I do for the denominator? I can't choose died, they didn't say that, and I can't choose hospital B. So that means I need to be out of the total. They're not giving me a condition. And when they don't give me given, of, or if, you need to put it over the total. So that's your answer. The probability of died and hospital B is 16 over 29. All right, let's do our last one. I'm almost at the 10-minute mark. Woo. Okay, so we have or. What's the percent of people who survived or went to hospital A? All right, or means I could be a survivor no matter whether I'm in hospital A or hospital B, or I could be in hospital A, whether I died or survived. So what I need hospital A's group, which is the 2100, and I need the survival group, which is the 2821. The problem is I have a number that is shown twice. If I was just to add hospital A and survive, which or in probability normally means to add. But the problem is I'm going to have too many people and I'm going to be over my total. So on the formula chart they give you, I just need to take away the number that is twice, which is the intersection. The 2,037 people is a part of hospital A and part of the survivors. So the math looks like this. 2821 plus 2100 minus 2,037. That is your answer to that problem. Okay. So now what I want you to do is turn on the back of your notes section, and I want you to try to go through those problems. When you get to the independence, which is on the right column of the second page, leave it alone. I am going to send the PowerPoint, the second part of the PowerPoint, to explain that and go over the answers. So I will see you, you will hear me in the next PowerPoint. Thanks.